All right, let us do some more examples. Okay, so next example I want to do is example number 18 from the book. Okay, what it says is integral of 3 over 2 root x 1 plus x. You see that plus? All these three formula, from these three formula you have that for sine inverse and secant inverse you have minus, right? For the tangent inverse you have plus. So we need to try to change that into tangent inverse there. Okay, so that means we need to do like 1 plus u square. What is the u? That you need to take u equals to root x, right? So root x square. So you know that what is the derivative of root x? So what is the derivative of root x? That is x to the 1/2 prime, right? That will be 1 over 2, and then x to the 1/2 minus 1. That will be 1 over 2 x to the negative 1/2, right? That will be 1 over 2 root x. You see that? So this can be written as, let me write 3 outside, and then I want to write 1 over 2 root x divide by 1 plus root x square. I'm just trying to change that into that formula, u prime over 1 plus u square, right? It is like 1 plus u square. The derivative of that root x is 1 over 2 root x. That is, I put that on the numerator as 1 over 2 root x. I'm not moving this to the numerator. I'm just writing 1 over 2 root x. You can write that way, because you know what? You can write a over b is equals to a times 1 over b. You can write like that. Then there is no problem. And divide by 1. You can write that way too. It's the same thing. Okay? That's why I was using that 1 over 2 root x in the numerator. Now, and then there is dx, right? What can you write for this? 3, and then you can write tangent inverse root x, right? Or that is tangent inverse. Okay, that is tangent inverse. So, and then root x. Okay, and then plus, see, that's what you get. Okay, how about here? On this problem though, you don't have 1. You need like, it is like u square minus, it is like x square minus, so it is like u square minus, so which should be secant square technically, right? But you need to have that format minus 1. There is no 1, there is 9 though. So we need to take out 9. If you take out 9, how does that look like? It looks like you have like root under 4x square minus 9, right? Let's take 9 out from there. So you get 9 out. So it is like 4 over 9x square minus 1. You see that? So this can be written as, take out 3 outside and then write as 2x over 3 square. U square minus 1, right? We need to make 2x over 3 here, no problem. But first of all, I want to write that way. Okay, so let us do that. So that will be, and it is a definite integral as well. There is root 3 through 3, right? So root 3 through 3, and then you have 1 over x. I want to write 3x because I took that 3 out from there, right? 3x, and under the root 2x over 3 square minus 1. It is like u square minus 1. Now you need u here and then u prime here, right? Because that's what the formula says, absolute value of u and then u prime on the top, right? What is the u prime on the top? That will be, you need 2x over 3 on the top, right? You need 2x over 3 on the top. Let me write down that secretly. So that is, I'm sorry, 2 over 3, not 2x over 3, because the derivative of 2x over 3 is 2/3. 2 over 3. So I need 3/2 here to cancel that out, right? Because I was just doing that extra thing here because I needed that. So 3/2 here, and here also you need 2x over 3, right? So you need 2x over 3. So what I'm doing here is I'm doing multiply by 2 over 3, okay, and then that will be, I am writing 3/2 here as well, right, to cancel that out. You see that? So 9 half is in the denominator. So you can write like this. This is like 3 half. Okay. And then you take that 3 outside. You don't need it 3. And then you write 2x over 3 here. So what is 9 half in the denominator? Divide by 9 half. That is the extra thing. This 3 half. And then that 3 is 9 half, right? And then you can write root 3 through 3. 2/3 over 2x over 3 under the root 2x over 3 square. I'm sorry, I should have used that red color or the pink color there. So it is like by the way, this is dx here, right? So it is dx. Now it is u prime over u times under the root u square minus 1. So it is, let me see, so you cancel that with that, that is 1/3. So 3. So that will be 1/3. Okay. And then root 3 through 3. And this, I don't need to write that again. I want to write just secant inverse. So that will be secant inverse 2x over 3 plus, you don't need plus c as well. Why? Because there is limit, right? Root 3 through 3. You see that? That's how you can write that way. Okay, guys? So next thing what I want to do is I want to use the limit there. Okay, how that look like if you put the limit there? So that will look like, so that was that will look like, let me see, so that will look like, I'm going to put it that. Okay, so that will look like this. That is 1/3. So plug in 3 first. You look like secant inverse 2 times 3, 6 over 3. You see that? 2 times 3, 6 over 3 is 2. Secant inverse 2 minus secant inverse, plug in 3. So you will get 2 root 3 over 3. 2 times root 3 over 3. You see that? 2 times root 3 over 3. So if you use calculator for that secant inverse 2, you will get, there is 1/3 there, that will be pi over 3. Minus, if you use that in your calculator, you will get pi over 6. Okay, and if you do this, is like 2 pi over 6 minus pi over 6, right? So it will be 1/3 times pi over 6, that will be pi over 18. That is the final answer. Okay, guys? All right. Next example that I am going to take is question number 33 from the book. So here there is sine inverse x and there is 1 minus x squared. It looks like the derivative of sine inverse x is 1 over 1 minus x squared. So let's do substitution. Sine inverse, because it is like sine inverse u times u prime, right? You see that? So it is like 1 minus 1 over u squared times u prime, right? So you can think like let sine inverse x equals to u. Find the derivative. 1 over 1 minus x square root dx equals to du. It is like sine inverse u x is u, right? So this can be written as integral 0 to 1 over, let me not write the limit first because I'm changing everything to u, right? Or if you want to change that to u, let us do that, because I haven't shown you how to do that before, right? Let me do that. So when x equals to 0, u equals to sine inverse 0. Okay, u equals to sine inverse 0, which is 0. When x equals to 0, this implies u equals to 0, and when x equals to 1 over root 2, then this implies u equals to pi over 4. That's what you will get. Okay, so this everything changed to u now, 0 to pi over 4, and then u, and then du, right? So how is that? That is u square over 2, and then 0 to pi over 4. If you don't change the limit, you can just plug in back the x values there. Okay, sine inverse x, and then you will plug in those values. Okay, so that is 1/2 u square is pi square over 16 minus 0 square over 2, right? Oh, pi square over yeah, pi over 4 square, right? You just replacing u by pi 4, and then 0 square over just 0 square, because you don't need, because I pull that 1/2 outside there. You see that? So how does that look like? This look like pi square over 32. That's what it looks like. Now number 36, there is plus. So do you remember squaring from college algebra? Complete the square. So you can write this as negative 2 to 3 dx. I can write this as like x squared plus, and then 4x plus 4, right? And then plus 4. You see that? Plus 4. So what I'm going to do here is I'm writing this thing as complete square completion form. That is x plus 2 square, right? Like x plus 2 times x plus 2. That will look like, let me write down that will look like negative 2 to 3, and then dx over, I can write 4 plus x plus 2 square. That 4 I wrote on at the front. And since there is a plus, I want to use tangent inverse there. Okay, so how that look like? That will look like equals to 1/4. I'm taking 4 out. Okay, and integral negative 2 to 3 dx over, you can write 1 plus x plus 2 over 2 square. Does that make sense? I'm taking 4 out. When you take 4 out, you will write 1 plus that over 4. So I can write x plus 2 over 2 square. Now what is the derivative of that thing? That thing is, derivative of that is 1/2, right? So you need 1/2 on the top, okay, and then multiply by 2, or you can divide by 1/2. It's the same thing. 2 there. So 2 and 1/2 will cancel out. So it's the same thing, right? So it is like 1 plus u square and u prime on the top. So it is tangent inverse, right? So what can you write here? There is 2 over 4 is 1/2, okay? And then that will be tangent inverse x plus 2 over 2, and then limit is negative 2 to 3. What do you get there? If you do that, what do you get? So that will look like, let me see that. So it will basically look like, oh, by the way, that is equals to that. So plug in 3 here. What do you get? 1/2. Okay, if you plug in 3, you will get tangent inverse 3 plus 2 is 5 over 2. Tangent inverse 5/2, and then minus, now we plug in negative 2, right? What do you get? Tangent inverse negative 2 plus 2 is 0 over 2 is 0. Tangent inverse 0 is 0, right? So 0, just you don't need that, minus 0. So the final answer is 1/2 tangent inverse 5 over 2. That's it, because minus 0 will go away. So you don't need that. You don't need to write that one. Okay, that's the final answer. Now here, how do I do this one? So what you can do this one here is basically, you can write 2 over the same technique, right? There is a minus. What I'm going to do here is I'm going to write like this, under the root, okay? What I'm going is, I want to write like this. So minus x squared minus 4x. It's okay, right? I'm just taking negative 1 outside here. So I want to do something here. So, and then there is dx, don't forget that. So this is a little bit tricky, right? So 2, there is a dx on the top, and then right, let me add 4, and then do minus, do x squared minus 4x minus, plus 4. How about that? What I did, if you distribute this minus, you will get negative 4. 4 and negative 4 will cancel out, so you will get the same thing. But I want to use that formula there. I want to change into that formula. Okay, so, and I want to take, so how can I write this one? So this can be written as x minus 2 times x minus 2, that factor. So you can write this as integral of 2 over 4 under the root is there minus x minus 2 square and then dx. Again we need 1, so I need to take 4 out. If you take 4 out, how that look like? So 4 minus x minus 2 square under the root, right? Take 4 out. So it will look like 4 and then 1 minus x minus 2 squared over 4, right? If you distribute, you will get that. Now this is x minus 2 over 2 whole square, and then that 4 will come as a 2 outside, right? That's what you can do here. Okay, so let me remove that. Okay, so you get equals to, take 2 outside, so integral 2 over 2 under the root 1 minus x minus 2 over 2 square. That square is for everything, right? So that 2 and 2 cancel out, dx. Now think of this. So it is like under the root 1 minus u square, under the root 1 minus u. So you need u prime. What is the u prime? What is the derivative of x minus 2 over 2? So x minus 2 over 2 can be written as x over 2 minus 1, right? 2 over 2 is 1. So the derivative of x over 2 is 1 half minus 0. So 1 half, you need 1 half on the top and bottom. So you need 1 half. Let me write 1 half here so that this can be written as sine inverse, right? So it is like 1 half. So on question number 40, there is no limit of integration, so we are okay. And then that can be written as sine inverse x minus 2 over 2, okay, and then plus c. That is the final answer, okay. And the very last problem for this section is root under x minus 2 over x plus 1, and the hint is given in the book. It says set u equals to root under x minus 2. That's the hint is given there, okay. Set u equals to root under x minus 2. Then if you square it, what do you get? Oh, there is dx, by the way. There is dx, I forgot that. Okay, so if you square it, what do you get? If you square it, then you will get u square equals to x minus 2, right? So what is x then? X is u square plus 2. So on this x, you can write u square plus 2. Okay, you see that? This x will be u square plus 2. Let me write down that way, okay? So integral, and how about the dx though? What will be dx? If you find out the derivative of that, you will get 2u du equals to dx. You see that? So 2u du will be dx. Okay, so we are replacing this by u. Okay, so dx will be written as 2u du. All right, so let us replace that. So you can write integral of u times 2u du over u square plus 2 plus 1. So what do you get here? You can write 2u square, the 2 is outside, so you can write 2 and integral u square du over u square plus 3. Okay, so what do you get here then? So you can write this as, so you see that they have the same degree on the numerator and denominator. So it is a little bit tricky here. What I am going to do is u square plus 3 minus 6, because I want to cancel that. U square plus 3, like this. You see that? So du, we are changing everything in terms of u. So 2, I am doing u square plus 3 over u square plus 3 minus, you can write 2 times the 6, right? You can do 12 and then integral 1 over u square plus 3. What I did here is 2 times that, and then 2 times negative 6 is negative 12, and then 1 over that, and then there is du. Okay, so what is that? You cancel that out, right? What is the integral of 1? That is u. So it is like equals to 2u minus 12. So it is like u square. There is a plus sign, so we want to change into the tangent inverse. But tangent inverse need 1, but we have 3, so take 3 out. So you will get integral 1 over 3 out, 1 plus u over root 3 square. That will be basically u over 3 square, u square over 3, right? Because there is u square, so u square over 3, but I wrote u square over root 3, u over root 3 whole square. So take that out, that will look like this. So it will look like 2u and then minus 12 over 3, right? So that will be 4, and then integral 1 over 1 plus u over root 3 square du. So it is 1 plus u square format, right? But we need the derivative on the top. So what is the derivative of this? It will be 1 over root 3. Let me multiply root 3. Let me divide by root 3 here. Okay? So now it is the tangent inverse u over root 3. So basically what you got from after that, let me write down here. 2u is what? Root under x minus 2 minus 4 over root 3 tangent inverse u over root 3. What is u though? U is x minus 2. X minus 2 over 3 under the root. You see that? And then plus c. That's what you get. That is the final answer. Okay guys, so that is the end of section 5.8. okay, and that is basically the end of this chapter. So we are not covering the hyperbolic function for now. If the time permits, we will cover that at the end of the semester. Okay guys, all right, thank you.